This is Math 2, Unit 9, Lesson 4. At this point, everyone should have out their notebooks, a calculator, and a pencil or pen, something to write with, as well as your packets. Make sure you have your packets out as well. Okay. The title will be Greatest Common Factor. You worked with greatest common factor back in elementary school. Now we're going to take that and apply it to factoring using the greatest common factor. Okay, I'm going to put here factor each polynomial, and I'm going to put in parentheses GCF. What does GCF stand for? Greatest common factor. So all we're going to be doing today is factoring using the greatest common factor. There will be other factoring methods eventually, but for today, it's just the greatest common factor. Again, we'll learn trinomial factoring, difference of two squares factoring. Next year, you'll learn cube factoring. So there's a bunch of factoring methods. For today, just the greatest common factor. Okay, number 1. 18a plus 27. Now, if you remember, I told you guys in our last class, that was Monday, that we were going to be working backwards. I'm just going to bubble it over here because I didn't make a section for a review. If I gave you something like this and asked you to multiply, go ahead and write this down. If I gave you 2x parentheses x plus 5 and asked you to multiply, remember what we talked about in notes, you multiply the coefficients and add the exponents. 2 times 1 is 2, 1 plus 1 is 2, so 2x squared. 2 times 1 is 2, x times x is x squared, plus 2x times 5 is 10x. And that would be your answer. So today what you're doing is I'm giving you the answer and asking you what the original problem is. So here is what you do. You're going to look to see what goes into 2 and 10, what's the greatest common factor, and that would be a 2. That's where that 2 comes from. X squared and x, this one has 2 x's, this one has only 1 x. I'm just going to write it out like this. 2 times x, this is 2 times 5 times x. How many things do they have in common? They have a 2 in common. And this has 2 x's, this has 1 x. What's the greatest amount they have in common? Just one of the x's. They don't have the extra x in common, just the 2x. And that's where that 2x is coming from. Okay, does that make sense? So again, we're not going to expand it all out like this. We're going to use what we've learned about greatest common factors, like what's the biggest number that can go into 2 and 10? That is 2. Now, a little trick we will use, there's a power of 1 here. You will, even though it's the word greatest common factor, you think biggest, even though it's greatest common factor, you always take your smaller exponent. That's a 2, that's a 1. You always take the smaller exponent. The reason is, that's the maximum amount you have in common. If I only have 1, even though I have 2 over here, the maximum amount I have in common is just the 1. Okay, so let's try this one here. 18a plus 27. What goes into 18 that also goes into 27? You can use your calculator, you can use your head. You could break down if you're stuck. You can break down in the factor tree and then do what we did here, look for all the common factors. The largest common factor is a 9. This has an a. This does not have an a. So a is not part of my greatest common factor. My only greatest common factor here is just 9. Why is it just 9? Because there's no a over here that it would have in common. 9 times what is 18a? 2a. There is a plus sign. 9 times what is 27? And that is 3. And that there is your answer. Before you box it in, there are a few things you have to check. It was 2 terms to begin with. There should be 2 terms in your parentheses. 2 and 2. Check. 9 times 2 is 18a. 9 times 3 is 27. Check. The last thing you have to check that kids always forget and they end up messing it up is look inside and you're checking if there is still a GCF. Does 2 and 3 have a GCF? No. Then you are done. This is your final answer. If there was still a GCF in here, that means your 9 was not big enough. And we'll get practice as we go looking at some of those. Okay, number 2. 14 x to the third minus 42 x squared plus 21 x. Okay, again, you can use your calculator. You just know it in your head. You can use the factor tree, break down the 14, break down the 42, break down the 21, and look for all your common factors. But I'm hoping you've had enough practice with like common denominators and stuff where you know how to work with common factors. The largest number that goes into all 3 of these is a 7. 7 goes into 14, 7 goes into 42, 7 goes into 21, and that is the biggest number that goes into all of them. Okay, now they do all have an x, which means x is part of my GCF. Which one do I take though? X to the third, x squared, or x to the first? Remember what we said earlier, you always take the smaller exponent. The reason is there's 3 x's here, there's 2 x's here, and there's only 1 there. How many do they have in common? Just the 1. They don't have any more than that 1 in common. So 7x is your greatest common factor. All right, 7 times what is 14? 2. Now, technically you're working backwards because you're multiplying the coefficient. 7 times 2 is 14, so you do 14 divided by 7 is 2. Or what I said, 7 times what is 14? It's 2. Now remember, you add the exponents. So what power here would I use for 1 plus blank is 3? This would have to be a 2. Can you see that 7 times 2 is 14? X times x squared is x cubed. Multiply the coefficients, add the exponents. Okay, minus 7 times what is 42? 6. Now I want an x squared. I have an x to the 1, so x to the first power because 1 plus 1 is the 2. 7 times negative 6 is 42. X times x is x squared because you add the exponents. Multiply the coefficients, add the exponents. Plus 7 times what is 21? 3. Now be very, very careful here because kids always mess this up. They do this. Do not write it on your paper, but they write that. Because they see that x there, so they're like, oh, 3x. Be careful because 7 times 3 is 21. But remember, there is a 1 here. And 1 plus 1 is not 1, right? 1 plus 1 is x squared, and that's not what this is. So you would either put x to the 0 or just put no x at all. All right, so before we box it in, 1, 2, 3 terms to start with. How many terms? Cover that one. How many terms in our parentheses? 1, 2, 3. Trinomial, trinomial. Let's do a quick multiplication. 7x times 2x squared is 14x cubed. Multiply coefficients, add exponents. This one here gives me negative 42, and x times x is the x squared. And then here, 7x times 3 is indeed 21x. 7x and 3 is 21x. No extra x here. Oh, and then check to see if there's still a GCF. Is there a common factor with 2, 6, and 3? No. 2 goes into 2 and 6, but it does not go into 3. 3 goes into 3 and 6, but it does not go into 2. So there is no more greatest common factor. This here is your final answer. All right, we're going to continue practicing. Number 3, 7y to the third, z to the fourth, minus 15y z squared. All right. Now, what is the largest number that goes into 7 and 15? Does it have a common factor other than 1? No, and you really don't ever treat 1 as a GCF. So there is no greatest common factor for the 7 and the 15, but they do have variables in common. There's multivariables here, so I'm going to put a 1 there. Between the y and the y cubed, we always take the smaller one, so we're going to take y to the first. Z squared and Z4, we always take the smaller one, so we're going to take Z squared. That there is my GCF. Sometimes my GCF is just a constant. Sometimes my GCF just has a variable or variables. And sometimes it has a constant or a coefficient with a variable. So just a number, just a variable, number and a variable. It just depends on the problem. Here, there was not an A on every single term. Here, 7 and 15 doesn't have a common factor, but they have common variables. And here, they had a common number and a common variable on every single term. All right, so there's a 1 here. 1 times what is 7? 7. And again, that 1 in the front, you do not have to put that 1 there, but you should know that it is there. Okay, 1 times 7 is 7. Now, I needed to add up to y cubed. So y to what power? 2. 1 plus 2 is 3. Z to what power? If I needed to add up to 4, that would be a 2. Y times y squared is y cubed. Z squared and z squared is z to the 4th. Minus. Remember, there's a 1 here. 1 times 15 to give me the 15. Now, y to the 1, and I want y to the 1. Should I put another y in there? No, I should not, because y1 and y1 make y squared, which that is not. So I am not going to put a y variable there. All right, z squared and z squared, should I put a z there? I should not, because z squared and a z1 make a z cubed, which that is not. So it's just the 15. Why just 15? Because when I multiply this here, I get the negative 15. They already have a y1. There's already a z squared. Everything's taken care of. 2 terms and 2 terms. Check. When I multiply, 1 times 7 is 7. At the exponents, y3, z4. That worked. 1 plus negative 15 is negative 15. There's no variables here, so it's just yz squared, which it is. Check. 7, 15, there's no greatest common factor. The 15 has no z or y, so there's no common variables. This is indeed your final answer. Okay, number 4. 4x cubed plus 12x plus 14. 4x cubed plus 12x plus 14. Sorry. And I'm going to change that 14. That 14 should have been just a 4. 4x cubed plus 12x plus 4. All right, so we're looking for the greatest common factor. There's 3 terms here. 1, 2, 3. What goes into 4 that also goes into 12 that also goes into 4? The largest number that goes into all 3 is a 4. This has an x cubed. This has an x. This has no x at all. If any one of them does not have a variable, you cannot take the variable out. If it was just there, there would be a common x. But since this has no x's, I cannot make x part of my GCF. It's just the 4. Again, why is it just the 4, not a 4x? Because this guy at the end has no variable. So I can't make x part of the GCF if it's not common on all 3 terms. All right, 4 times what is 4? That is 1. You don't have to put the 1, but you should know it's there. There's no x here, so this must be an x cubed, because 4 times 1x cubed is 4x cubed. Plus 4 times what is 12? That is 3. And I'm going to put the x, again, because there's no x out here, and I need an x. 4 times 3x is 12x. And then this is where kids mess up. They're like, oh, 4 came out, so they close the parentheses. Do not do that. There's 3 terms here, and there's only 2 terms in here. That is incorrect. There is a number. 4 times what is 4? That is a 1. Don't forget, just because you pull it out and it's gone completely, there's still something left there. It's a 1. Now let's check. 3 terms. 3 terms. That's good. 4 times 1x cubed is 4x cubed. 4 times 3x is 12x. 4 times 1 is 4. Oh, and there is no GCF. 1, 3, 1. There's no greatest common factor anymore. This is your final answer. All right, number 5. I'm going to give you a bit of a tricky one. And it's not tricky, it's just complicated with the numbers. 32 z to the 4th minus 80 z to the 3rd plus 112 z squared. Some big numbers. I'm going to give you guys a few seconds to figure out what the greatest common factor is. What's the largest number that goes into 32, 80, and 112? I'm going to give you guys a few seconds to do that now. Largest number that goes into 32, 80, and 112. Okay, I'm going to go ahead and start working it out with you. If you haven't found the number yet, that is okay. The reason I give you this problem, I'm going to put a little star by it because this is a good one to get practice on using that trick that I've said about checking if there's still a GCF, because that hasn't been a problem for us on any of them yet. But this would be one where it might happen. Okay, so first thing kids look at is the 32, the 80. They're like, oh, 8 goes into both of them. So let's try the 112. 112 divided by 8 equals 14. So 8 must be my GCF. If you didn't get 8, that's okay. We're gonna check it. Okay, Z4, Z3, Z squared. The smaller one is Z squared. Again, if there were 4 Z's here, and there were 3 Z's here, and 2 Z's here, how many do they have in common? 1, 2, 1, 2, 1, 2. That's the maximum amount of Z's they all have in common. So I always take the smallest exponent. Okay, 8 times what is 32? 4. Z, 2 plus what is Z to the 4th? That would be another 2. Z squared, Z squared, Z to the 4th. Minus 8 times what is 80? 10. I want Z cubed. I only have Z squared. So I put one more Z because Z squared and Z to the 1, when I add the exponents, I get Z cubed. And then plus, what did we say that was? Was that 14? Now Z squared, there's already a Z squared. Do not put another Z. Kids often do, but remember when you add the exponents, 2 plus 1 is not 2. So that's not going to have a variable there. Why? Because 8Z squared times 14 is 112Z squared. The Z squared's already taken care of. Okay, so we do our check. 3 terms, 3 terms. That's good. 8 times 4 is 32. Z squared is Z to the 4th. That's good. 8 times negative 10 is negative 80. Z squared and Z to the 1st does add up to Z cubed. And 8 times 14 is 112. And Z squared and no Z make the Z squared. Now here is why it is wrong. Now if any of you got that, or you paid attention to me and you're like, why in the heck is it wrong? Everything makes sense. I'm going to explain why, or how you can tell. Because when you check, the 3 terms match. When I distribute, it matches up perfectly. Why in the heck is it wrong? And I get this question every year, so this is what you do. Do not forget to check if there's still a GCF inside. I kept saying that, and it hasn't been a problem until now. Is there still a number that goes into 4, 10, and 14? Don't pay attention to the negative signs. Is there still a number that can divide into 4, 10, and 14 evenly? They're all even, and 2 is the largest number that goes into all of them. 2 goes into 4, 2 divides into 10, and 2 divides into 14 evenly. Which means 8 was not my greatest common factor. Yes, 8 was a common factor, but it's not the greatest common factor. So here's a trick on how to do that. Do your 8z squared times your 2. 16z squared is your true GCF. Now, I don't know if any of you had that to begin with. If you did not, you're fixing it now. Again, what was the trick? Take the GCF out that's still existing and multiply it by your original GCF. 8 times 2 is 16. And z squared was big enough because you can see they do not all have z's anymore. This one does not have a z, which means you took enough z's out. Okay, so we're starting over. 16 times what is 32? You can divide that in your head, by hand, in your calculator. 32 divided by 16 is 2. 16 times 2 is 32. My variables are going to be the same. Z squared to give me z to the 4th. Minus 16 times what is 80? Do it in your head, by hand, in your calculator. 80 divided by 16 is 5. Again, the z is going to stay z because z squared and z1 make the z cubed. Plus, and then do 112 divide by 16. Plug it in your calculators now. And that gives you 7. Now just 7, because remember, z squared and z squared, I don't want to put another z, that'll make a z cubed. So that there is your answer. There's 3 terms. When you distribute, it ends up being the original problem. And take a look there, 2, 5, 7. There is no more GCF, which means that is your final answer. So if you get back a quiz, and it's a GCF problem, you get it wrong, before you come up and ask me, why is it wrong? Check inside to see if there's still a GCF. If there is, that means your original guess, your original GCF was not big enough. 8 times 2 is the 16. That's the biggest, greatest common factor. All right. This next one is another tricky one that comes up on the test that isn't really hard. It's just, it looks different, and so kids struggle with it. All right, so I'm going to put a little note here. This is on the test. Please don't miss it. I'm telling you now it's on the test. It is. These are all on the test, but I like to point out the ones that kids typically struggle with. Okay, it looks like this. X plus 3, quantity squared, minus x plus 7 times x plus 3. The quantity of x plus 3 squared minus the quantity of x plus 7 times the quantity of x plus 3. And we're still going to factor out using the GCF. Okay, so it does look funny. Do not distribute, do not do anything, leave it as it is. Here's what you do. First off, recognize that there are 2 terms. That's a big chunk, but it's 1 term. This is a big chunk, but it's 1 term. There are 2 terms. And again, terms are held together by multiplication symbols. So I'm just going to rewrite this one as x plus 3 times x plus 3, and then x plus 7 times x plus 3. Do you see how I did that? I just wrote that twice because that's what the squared power does, and I just rewrote this one as it is. Okay, here are my 2 terms held together with the subtraction sign. What is a common factor? Okay, so that's 1 term with 2 factors. I'll show you there. That's 1 term with 2 factors. This is 1 term with 2 factors. Do either one of these terms have a common factor? Would you agree they both have an x plus 3? That is the only common factor it has. This has another x plus 3, but this does not match. That's an x plus 7. The only common factor they have is the x plus 3. So you take that out as your GCF. And it does go in parentheses because you can see they're in parentheses to begin with. All right. I'm going to put brackets here. And the reason is because I'm going to have parentheses inside. All right. If I take out an x plus 3 from this first term, that leaves me with one other x plus 3. Takeaway. If I take out an x plus 3 from this one, that leaves me with x plus 7. And that there is your answer. I know it looks wonky, it looks funny, or like, what the heck is she doing? That is your answer. That is it for now. When you get to higher level math classes, you can't leave it like this. You'll have to distribute the negative, combine like terms, but for now, that's all we're doing. We're leaving it looking just like this. And you can check, there's the two terms. Here are my two terms. There's no more common factor in there. X is not a common factor, because it's x plus 7, not x times 7. Okay, so there's no common factor. And if you were to multiply these two, x plus 3 times x plus 3, it's x plus 3 squared. And x plus 3 times x plus 7 is x plus 7 times x times plus 3, with the minus sign in the middle. Let's try one more just for practice. Number 7, x plus 7 cubed plus x minus 4, x plus 7. Now, I'm going to rewrite it. X plus 7 cubed, again, there's two terms. X plus 7 cubed means there's 3 of the x plus 7s. And then x minus 4 and x plus 7. All right. Two terms. First term is a little bigger, second term is a little smaller. The second term has 2 factors. The first term has 3 factors. They're all the same, but they're still 3 factors. All right, do they have a common factor? They have a common factor of x plus 7 and x plus 7. Do they have any more common factors? They do not. This has another x plus 7, but this one does not. So x plus 7 is the greatest common factor. So I bring it out as an x plus 7. Put my brackets. Okay, so x plus 7 came out. If I factor it out, what's left over here? X plus 7, and I'm going to rewrite it now as squared because there's 2 of them. You add the exponents, it's squared. Plus, if I took the x plus 7 out of that one, that leaves me with x minus 4. And that there is your answer. So you can see there's 1, 2, there's 2 terms. There's 2 terms. X plus 7 times x plus 7 squared, if you were to add the exponents because the bases are the same, it's x plus 7 cubed. X plus 7 times x minus 4 is the x minus 4 times the x plus 7. So it does indeed work. We'll get more practice with these as we go through the unit. Okay, what I'd like you guys to do now is take out your packets. Take out your packets and open up to worksheet 4. Take out your packets and open up to worksheet 4. And I'm going to do a few of them with you to get you started, just to kind of go through and review what is what. Okay, I'm doing number 3. So, factor out the greatest common factor for each polynomial. Okay, what's the largest number that goes into 72 that also goes into 63? Remember, if you're stuck, you can do your factor trees. Factor trees, get all your list of numbers and circle the ones that are in common. Not the pairs, just the ones that are in common. All right, so I'm hoping you can recognize that 9 is the largest number that goes into both of them. And this has an x squared, but that has no x. So x is not part of my GCF, it's just the 9. Why not an x? Because there's not an x over here for me to take out a common factor of x. 9 times what is 72? 8. And then the x squared, since there's no x out here. 9 times 8x squared is 72x squared. Take away 9 times what is 63? 7. 2 terms, 2 terms. There's no GCF here, so I'm good. 9 times 8 is 72, x squared. 9 times negative 7 is negative 63. This is the final answer. Okay, next one I'm going to do is number 8, 24, 36, and 42. All right, so you're looking for a common factor. When I see it, the first thing that pops out to me is 12. 12 goes into 24 and 36. So you can check, does 12 also go into 42? 42 divided by 12 is a decimal, it's 3.5, which means 12 is not my greatest common factor. So let's try maybe something a little bit smaller. I can see that it's even. 2 goes into all of them. I can see, well, 6, I know 6 goes into these two. 6 goes into 24, 36. Does 6 also go into 42? It does. So I'm going to try 6. Y to the 6th, y to the 4th, y to the 2nd. Remember, you take the smallest exponent always, because that's the maximum amount they have in common. Greatest common factor. And the greatest amount they have in common is the squared. Okay, parentheses, 6 times what is 24? That is a 4. Y to what power? Remember, you want it to add up to 6. You already have a 2, so that is a 4. And 6 times 4 is 24. Y squared and y4 add up to y to the 6th. Plus 6 times what is 36? That is a 6. You may be thinking, oh, there's still a GCF there. Well, let's keep going. Y squared, and then I need y to the 4th, so what's my power here? That's a 2. Y2 and y2 add up to y to the 4th. Plus 6 times what is 42? 6 times 7. Now remember, as tempting as it is to put a y, 2 plus 1 is not 2. There is no y there, which makes sense because if there was a y, there would still be a greatest common factor. Okay, let's check. 3 terms. And now take a look. 4, 6, and 7. Is there a greatest common factor still? There is not. There is with the 4 and the 6. 2 goes into both, but 2 does not go into 7, so there is no more greatest common factor. Okay, 6 times 4 is 24. Y squared and y to the 4th make y to the 6th when you add. Here, multiply the coefficients, add the exponents. 36y to the 4th. Here, just multiply because they don't have a like variable, and that gives me 42y squared. All right, let's take a look at number 10. 13 and 39. 13 is prime. So the only number that can go into 13 is 1 and 13. So check if 13 can divide into 39 evenly. And it does. So 13 is part of my greatest common factor. They both have a c. This is c to the 1st power. That's c to the 2nd power. I take the smaller exponent. This is d cubed. That's d squared. I take the smaller exponent. Now notice, this is not cd squared, nor is this cd squared. Where did I get this from? Looking at my c's only, c to the 1st power is a smaller one. Looking at my d's only, d squared is my smallest exponent. All right, 13 times what is 13? 1. You do not need to put the 1 there, but you can. And I don't need to put it there because there's variables still. If there were no variables, the 1 would be necessary. Okay, c to the 1st, I cannot add another c. D squared, I need it d cubed, so I'm going to put d to the 1st. 13 times 1 is 13. C to the 1st times nothing is c to the 1st. D squared and d make the d cubed. I'm good. Plus 13 times what is 39? That is a 3. C to the 1, I need it to be c squared, so I need another c in there, so when I add the exponents it gives me c squared. Okay, d squared, it's already d squared. I cannot add another d because if I do, it will not add up properly. The d is not there because d squared is already taken care of. This here is your answer. There's 2 terms. There's no GCF between 1d and 3c. And if you were to distribute, it would come out to be the original problem. All right, let's move on to the bottom of the page. I'm going to do number 16. These are the ones I did at the end of notes. Remember, there's an x minus 8 and an x minus 8, minus x minus 8 and x plus 2. two terms. In my first term, there's two factors. In my second term, there's two factors. Do they have any common factors? Well, they both have an x minus 8. That's one common factor. Is there anything else in common? There is not. That has an x minus 8. That has an x plus 2. The x minus 8 is my greatest common factor. It's the greatest amount they have in common. When I pull out the x minus 8, this leaves me here with another x minus 8, minus this one leaves me with x plus 2. And that there is your answer. X minus 8, if you were to distribute, x minus 8 times x minus 8 is indeed x minus 8 squared. X minus 8 times x plus 2 is indeed x minus 8 times x plus 2. All right, let's flip over to the back side. And remember, whatever I don't do with you, you finish on your own. All right, I'm going to do number 20. These type 19 and 20 are test questions, so you want to make sure you understand them. A square, it's important to know it's a square, has a length of 2x minus 7 feet. Find the area of the square. Express your answer in this form. Be sure to include the units in your answer. Okay, remember, if it is a square, that means the length and the width are the same. So it's 2x minus 7 by 2x minus 7. A rectangle, that's not going to happen. That's why they give you two different measurements. But for a square, they're going to be exactly the same. Now, how do you find the area of a square? You do length times width. Length times width. So my area equals 2x minus 7 times 2x minus 7. The area is the length, 2x minus 7, times the width, 2x minus 7. Now I'm just going to rewrite it up here so I have room to show my work. Now remember, this is what we did on Monday, and we do double distribution, or the FOIL method, or the rewrite method, or the window method, whichever one you like. I'm going to do double distribution. Okay, so I'm going to distribute the 2, I'm going to cover that one. I'm going to distribute the 2x to that one and that one. 2x times 2x, you multiply the coefficients and add the exponents, is 4x squared. 2x times negative 7 is negative 14x. And now this is the double part. That was the first distribution. The second piece is distributing your negative 7. Negative 7 times 2 is also negative 14x. Negative 7 times negative 7 is positive 49. All right, like terms. 4x squared minus 14x, negative 14x, and negative 14x is negative 28x plus 49. And that's the form they asked for it. Ax squared plus bx plus c. Ax, they just used a, b, c for the constants, the coefficients. So a is 4, b is negative 28, c is 49. It doesn't really matter, but they did ask for our units. I'm going to put parentheses. Remember, when you do length times width, it's units squared, so feet squared. That there is the area of my square. Definite test question. I did length times width, double distribution, combine like terms, and I am done. 4x squared minus 28x plus 49, and do not forget your feet squared. You do not want to get docked points for that. All right, 21. And keep in mind, all of these on the back page are review. All of this back here is review. Multiply, just like what I did here. I'm going to do double distribution. If you like the window method that I showed you guys, you would do x positive 5, x negative 5, and fill everything in. People like that because it helps them keep things organized. I'm going to continue to do double distribution. X times x is x squared. X times negative 5 is negative 5x. Again, I'm going to cover that 5. x times x is x squared. X times negative 5 is negative 5x. Now I'm going to distribute the positive 5. Positive 5 times x is positive 5x. Positive 5 times negative 5 is negative 25. If you were doing it here, you'd have x squared, 5x, negative 5x, and negative 25. You do not have to do it that way. That's just if you prefer. Okay, combine your like terms. Because they are opposites, they do cancel each other out or undo each other. Negative 5x plus 5x is 0. It's gone completely, so you're left with x squared minus 25. And we will work backwards from those eventually as well. All right, what's the difference between these two? These were exactly the same. When they were exactly the same, the middle terms do not cancel out, they combine. This was a plus 5, a minus 5. Again, we call those conjugates, x plus 5, x minus 5. When we did our double distribution, and I forgot my arrow there, when we do our double distribution, these end up being opposites. They undo each other or cancel each other out, leaving that as your answer. Okay, I'm not going to do this one all the way. I'm just going to rewrite it for you. X minus 8, x minus 8. And that's going to be more like this one because these two signs are exactly the same. When you do your double distribution, your middle terms will not cancel out. You will have to combine them like we did to that one. All right, I have this one circled, but I'm going to stop here and I will do these with you guys in class. Try them on your own, do the best you can, and then I'll do them with you when I get back on Friday. All right, continue working. If there's time, continue working. Whatever we didn't finish together, you're doing on your own, either in class, and whatever you didn't finish there, then it becomes homework.